Hi everyone. In this video we will address with you the IUOPAC nomenclature for carboxylic acids. Carboxylic acids are the king. During this video you will see by yourself how the carboxylic acid has a priority in all function groups. But before continue this video, please, if you didn't subscribe and activate the bell ring, as well as share this work with your colleagues and friends. Let us start. Carboxylic acids of function group are COOH. So COOH, this is carboxylic group. You have to put in mind some points. The first one, carboxylic acid should be always number one. This is the king. So whenever you see carboxylic acid, it should be numbering number one. Second point, proceed with route as longest chain including carboxylic acid. Here is the point. We know, everyone know that route, this is the longest chain, okay, no doubt. Here what's new. For carboxylic acid, routes, this is the long chain including carboxylic acid. So if you see any compound contains carboxylic group and any other group, say for example long chain but not directly attached with carboxylic acid, so it's not the root. It is not the root. So the root should be attached with carboxylic acid directly. Third bond, suffix. Suffix, put it as oic acid. Oic acid. And last thing is prefix. Prefix numbers the side group or groups according to numbering direction and priority. Let us see this example. We have 3 carbons, 1, 2, 3, and we have carboxylic group COOH. The carboxylic acid should take number 1. So 1, 2, 3. Okay. At carbon number 2 we have 2 methyl, 1 methyl and 2 methyl. So 2 and 2 dimethyl propanoic acid. Propanoic acid. Propane, since there are 3 carbons. Oic, since it is carboxylic acid. So 2 and 2 dimethyl propanoic acid. Here it is a comparison listing between IUOPAC name and common name. We focus here as an IUOPAC, but just in case, you have to bear in mind that there is very famous and very common names you should know in organic chemistry as well. First one is the simplest one, only one carbon, HCOOH. So the root here, I am talking about IUOPAC. The root here from methane, suffix here in, and the secondary suffix is oic acid. So it is methanoic acid. Methanoic acid. Methanoic acid. Second one, if you increase one carbon, the same. It is ethanoic acid. Ethanoic acid. Here 1, 2, 3, 4. So it is isobutyric acid as common name, and about IUOPAC name, the prefix it is 2 methyl, and the root is propane, and the suffix will be oic acid. So it is 2 methyl propanoic acid. 2 methyl propanoic acid. Here I would like to mention that in previous video on alkenes, alkynes, I have highlighted that you can consider condensed structure, and you put some groups between brackets. Between brackets means branching in organic chemistry. So you have to consider this. If you see any kind of branching here, which means that the structure is not straight, it is branched. So here it is branched, that's why here is a common name, it is iso. Iso means 3 carbons in right angle. So here, if you numbering here, it will be 2-methyl propanoic acid. This structure, you have carboxylic acid beside phenyl group. So it is 1, 2, and phenyl. So 2-phenyl ethanoic acid. 1, 2, so 2-phenyl ethanoic acid. The common name here is oxalic acid, composed of 2 carboxylic acids so it is ethane 1 and 2 dioic acid. Di means 2. Oic acid means 2 carboxylic acids. So ethane 1 and 2 dioic acid. Same here, it is propane dioic acid. We have 3 carbons, terminals carboxylic acid here and there, from 1 and 3. So propane dioic acid. What about this one? This one, it is 4 carbons. Again, the terminal is carboxylic acids. So it is butane 1 and 4 dioic acid. 1 and 4 dioic acid. Here as well, it is 1 and 3 dioic acid. And this one, 1 and 2 dioic acid. Here in glutaric acid, you have 5 carbons. So pentane dioic acid, and the 2 carboxyl group entities from 1 and 5. So 1 and 5 dioic acid. The last one, it is adipic acid, as common name, composed of 6 carbons, terminals hydrocarboxylic acid in carbon number 1 and 6. So it is hexane 1 and 6 dioic acid. Let us take these examples regarding to the carboxylic acid and see how can we give reference and priorities. Here we have a chain. Can you consider this carbon? No, this is oxygen. So counting from here, this carbon 2, 3, 4, 5. So it is from pentane. And since all of this it is acid, so it is bentanoic acid. Bentanoic acid. Okay. Do we have any substitution or any function groups? Yes, we have methyl here. At which position? Position number 2. This is carbon number 1. This is carbon number 2. Here I would like to stress on something very important, and many people fall in the exam regarding to this. Carboxylic acid, this carbon should be counted. Why you dropped this in counting? This carbon should take number 1. So it is carbon. So in any numbering, you should number this number 1. 1, 2, 3, 4, 5. So this is 2-methyl bentanoic acid. Here we have acid. We have methyl group, ketone group, and isopropyl group. How many carbons here? 1. Why you said 1 from here? Why you didn't take here? Carboxylic acid has a preference. This is the king. So it should be number 1. If you remember when we talk about the ketone, I told you the ketone has a priority. Okay, priority compared to other function groups, as I mentioned before. But in presence of carboxylic acid? No. Carboxylic acid should be the king. It is number 1. So numbering should be from this carbon. 1, 2, 3, 4, 5, 6. So this is derivative from hexane. And since it is acid, it is hexanoic acid. Hexanoic acid. Okay. What about derivatives? 1, 2, 3, 4. At carbon number 4, we have this structure, which is isopropyl. Isopropyl. So 4 isopropyl. And at number 5, we have ketone, which is oxo. If you remember, this structure is oxo structure. Oxo. So 4 isopropyl, 5 oxo, hexanoic acid. Hexanoic acid. Consider this example. We have only one carbon. This is methanoic acid, which I have discussed before. And this is the simplest form, this formic acid. This one increase one carbon, this is ethanoic acid, which is acetic acid as common name. Increase another carbon, so 3 carbons, 1, 2, 3. So it is propanoic acid. Propanoic acid. This is the acid, and this is composed of 3 carbons, derivative from propane, so it is propanoic acid. Here we have cyclopentane structure, cyclopentane plus carboxylic acid. How can we numbering this structure? Okay, everyone knows that carboxylic group should take number 1. Okay, no doubt. So this is number 1. Can you give this number 2? No, my friend. This structure, this prefix. Prefix, you should follow rules of prefix. And carboxylic acid should obey rules of carboxylic acid. So this carboxylic acid named only carboxylic acid. Okay? Attached with cyclobentyl structure. Okay. When you consider numbering of this cyclo structure, you have consider alphabetically. So you consider this 1 and consider this 2. Not 1, 2, 3, 4, 5. No. 1, 2. So 1 chloro, 2 methyl, this is 2. 2 methyl, cyclopentane, carboxylic acid. Carboxylic acid. Okay? We have this structure, ionized form from hexanoate as ester. It is from hexanoic acid. In presence of sodium hydroxide, it is hexanoate, sodium hexanoate. Okay, this carbon number 1, 2, 3, 4, 5, 6, derivative from hexane. So it is hexanoate, and as you have sodium here, it is sodium hexanoate. This structure, we have only 2 carbons. As I told you before, this is oxalic acid as common name. So it is ethanedioic acid. Ethanedioic acid. Dioic means dicarboxylic acids. Here propane 1, 2, 3. So it is propane dioic acid. Propane dioic acid. Here 4 carbons 1, 2, 3, 4. It is butane dioic acid. Here we are applying the priorities and we highlight the suffixes. Look at this structure. we would like to nomenclate, either to nomenclate from this side or that one. This is C double bond OOH, which means this carboxylic acid must take number 1, no doubt. So 1, 2, 3, 4, 5. So 4-oxo bentanoic acid. This one, we have 3 derivatives. 1 chloro, 1 nitro, 1 bromo. So which rule we have to follow? Alphabetical, my friend. First of all, what about the longest chain, heptene? Since it is 7 carbons, 1, 2, 3, 4, 5, 6, 7. Or you can count from right to left. We will see right now which path forward we have to go through. Okay. Which one of these substituents should take from alphabetical point of view has a priority? Bromine. So we have to consider numbering from this side. To take bromine as the lowest number. So here it is 1 bromo, 4 chloro, 3 nitro, heptane. 1 bromo, 4 chloro, 3 nitro, heptane. This one, C double bond O and COH. Take care, my friend. This is not carboxylic acid, since this is 2 carbons. This carbon and this another carbon. But if you are talking about carboxylic acid, should be 1 carbon. Here, this is 1 carbon, C double bond O, OH. That's why this is acid. Here it is not acid, huh? You have 2 carbons, which is not acid. We have 2 derivatives, 1 ketone and 1 hydroxyl group. So we have ketone, hydroxyl, and cyclobentane. So how can we nomenclate this? Okay, what is the root? Cyclobentanon. Why? As I told you before, the ketone has a priority if you found hydroxyl group or alkyl group or aryl group or cyclohexyl group. The priority here for ketone. So you should take number 1. In doing so, you have to continue numbering. You can go through from clockwise 1, 2, 3, 4. You can't go anti-clockwise. In doing so, if you go through anti-clockwise, you will give this carbon at number 5, which is wrong. So here it is 1, 2. So 2 hydroxy, you have here 2 hydroxy. Cyclobentanone. What about this? This is COO something. So this is ester. Again, what is the chain? What is the root from butane? So this is derivative from butanoic acid. And this is ester from butanoic acid. So it is butanoate. Okay. This carbon should be number 1, 2, 3, 4. This is not carbon, that's why there is no giving number here from this side. So you will start here, continue like this. Here we have ethyl group and we have 4 mercapto group. This is mercapto. So ethyl, 4 mercapto butanoate. This structure we have double bond plus hydroxyl group. So 1, 2, 3, 4, 5. Again, I found here hydroxyl group and alkene group, which has a priority in numbering. The priority here should be giving to hydroxyl. So the carbon attached to hydroxyl group should be numbered at number 1. So 1, 2, 3, 4, 5. So at carbon number 4 we have ene, double bond. So we have bent, since it is 5 carbons, bent 4 ene, 1 ol. 1 ol. This structure we have triple bond, and we have 1, 2, 3, 4, 5. My friends, here exam tips highlighted here, common mistake. Many friends fall in this. Look at this arrow. This is carbon, my friends. Okay, this is carbon number 1. This is carbon number 2, not this. Bear in mind that this is this carbon, carbon, carbon. That's why numbering here 1, 2, 3. During the exam, you might be not concentrated well, and you consider this 1 and 2, with the result that your nomenclature will be wrong. Why I give here the priority for triple bond? If you back to my previous video, alkenes, alkanes, and alkynes, I told you that the triple bond has a preference if it is ended, if it is terminal. That's why this is ene group or triple bond has a priority in numbering, and take number 1. So what about the chain? The chain composed of 5 carbons, 1, 2, 3, 4, 5. So this is derivative from pentane. So pentane, 1 ene, 1 ene. And we have another function group, it is halide at carbon number 5. So 5 chloro bent 1 ene. 5 chloro bent 1 ene. Now at the end of this video, I hope that you could nomenclate the carboxylic acids as per IUOPAC system. And if you still have any comments or inquiries, you can drop it to me or email it to me in my email mentioned in this video. If you didn't subscribe, please subscribe and activate the bell ring. Share this information with your colleagues and friends, as well as if you like this work, please like it. See you in the next video. Bye.